Good day, everyone. Today, we will look at statistics. Our objective for today, determine the measures of dispersion for raw data, which includes range, interquartile range, and semi-interquartile range. What is statistics? Statistics is the discipline, that part of mathematics, that concerns the collection, organization, analysis, interpretation, and presentation of data. In applying statistics to a scientific, industrial, or social problem, it is conventional to begin with a statistical population or a statistical model to be studied. Let's look at a scenario. Gary was given the task of recording the times run by his teammates over 100 meters. Gary recorded the times in seconds as follows. So Gary recorded 15 of his teammates running the 100 meters. Raw data. The times recorded by Gary are considered raw data because they were not arranged in any order. They were not processed whatsoever. Gary now wants to see how dispersed the values are. But what is dispersion? Dispersion means to the extent to which a numerical data is likely to vary about a central value in a dataset. So Gary first needs to find the center of the dataset he has collected. So although we're dealing with dispersion, we do realize that we even speak about center here. He can also do so if he places them in order, or he can only do so if he places them in order, ascending or descending, smallest to largest or largest to smallest. He then needs to find the range. What is range? Range is given as the difference between the largest and the smallest values in a dataset. So, this is a dataset in order. Please note that we have dataset from the smallest, which is 11 seconds, to the largest, which is 13.2 seconds. Then the range is given by this formula. Largest data value subtract the smallest data value. If we substitute, that will be 13.2 subtract 11 seconds, The range is 2.2 seconds. What does the range tell us at this point? The value of the range found by Gary's data tells us that there is not a large dispersion in the data collected by him. Interquartile ranges. Another measure of dispersion. Gary needs to find the interquartile ranges, but before he can do so, he will need to know the quartiles. What are the quartiles? Of course, the question now exists. What are quartiles? Quartiles are values that divide a dataset into four quarters. Four quarters. They are called the first, second, and third quartiles, and they are denoted by Q1, Q2, Q3, respectively. Q1, which is the middle value in the first half of the rank ordered set data. Q2 is the median value in the set. Q3 is the middle value in the second half of the rank ordered dataset. So with the values ordered from smallest to largest, then we need to find out where the median, which is denoted by Q sub 2, would be. And we're saying median is the middle of an ordered dataset, that middle value, that single value within the middle of a dataset that is arranged in order. Okay, and one number that is associated with middle is half. So once we can locate halfway the data set, then we would be so happy to find the median. So this means that the median is the single data value that lies in the middle, halfway. So in this case, 12.2 seconds is the median. Of course, we have 15 values, so the median would be 12.2. So now for the lower quartile, which is denoted by Q sub 1. And of course, the lower quartile is the middle of the first half of that data set, which is actually quarter the way, or cuts the data set into one quarter. So this means that the lower quartile is a single data value that lies in the middle of the first half, of course. So in this case, 11.6 seconds is the lower quartile value. Upper quartile at the 3/4 mark, which is denoted by Q3. So this means the upper quartile is a single data value that lies in the middle of the second half of a set of data values. In this sense, 12.8 seconds is the upper quartile. Gary is now interested in the interquartile and semi-interquartile ranges. What is interquartile range? Interquartile range, denoted by IQR, is a measure of statistical dispersion, which is equal to the difference that is operative, equal to the difference between the 75th and 25th percentiles, or between the upper and lower quartiles. So it would be the difference between the upper and lower quartiles. So to find the interquartile range, Gary needs to find the difference between the upper quartile and the lower quartile. Of course, from your ordered set of data, we have used colors to highlight these values. So we know where Q3 is and we know where Q1 is in the data set. So all we need to do now is to substitute. So interquartile range after substituting will be 12.8 seconds subtract 11.6 seconds. So interquartile range is the difference between 12.8 and 11.6. That will give us 1.2 seconds. What is semi-interquartile range? Semi-interquartile range, or SIQR, is a measure of statistical dispersion, which is equal to half the difference between the 75th and 25th percentile, or half the difference between the upper and lower quartiles. To find the semi-interquartile range, Gary needs to find half the difference between the upper quartile and the lower quartile. Now with your ordered data set, we know where the upper and the lower quartile is. So this is the formula that we use to guide our process, which is Q3 subtract Q1 all divided by 2. So if we substitute within that formula, we'll have 12.8 subtract 11.6, then divided that difference by 2. That would be 1.2 divided by 2, or half of 1.2, which is 0.6 seconds. The scenario. So Gary was given the task to record the times for his teammates another day. Gary recorded the times in seconds as follows. Gary noticed that 3 of his teammates were missing during the day of training. He's now concerned about the measures of dispersion. Now remember, the first day it was 15, and now 3 less, that's 12. He then arranged the times in ascending order. Of course, ascending order from smallest to largest. He then repeated the processes to find the measures of dispersion as he did the first day of training. So let's look at the median. Of course, we use the median to show the dispersion around a central value. So we need to find the central value for these data. He attempted to find the median. Of course, he found that two values now were in the center. Let's see what he did. He found out that there were two values were central in the data set. However, he knew that the value of the median should be a single value. So he found the average of the two central values. So Q2, which represents the median, is equal to 12.4 plus 12.5, those are the two central values, divided by 2. When you add 12.4 and 12.5, you get 24.9, and then divide that by 2, we arrive at 12.45 seconds for our median. Our range, he attempted to find the range. Of course, we know from beginning that the range is found using the smallest data value and the largest data value. Finding the difference between the two. So 13.4 was the largest, 11.4 was the largest for this time. Range is equal to 2 seconds. Upper and lower quartiles. Of course, he attempted to find the quartiles, but he left that mark there to show exactly where the median was, because the median is actually a quartile in itself. Okay, so he calculated the quartiles, that's the lower and the upper quartiles, basically by finding the average of the two values that are within the center of each half of the data set. So of course, the lower quartile would be the average of 11.6 and 12. And the upper quartile would be the average of 12.9 and 13.2. So for lower quartile, it would be 11.6 plus 12, that is 23.6, divided by 2. Your lower quartile value will be 11.8 seconds. Upper quartile, you would find this sum of 12.9 and 13.2. That would give you 26.1. And that you divide by 2, you get 13.05 seconds. Interquartile range. Now we know that our IQR, interquartile range, is the difference between the upper quartile and the lower quartile. And that is 13.05 subtract 11.8. Result for your interquartile range is 1.25. Semi-interquartile range is equal to Q3 subtract Q1 all divided by 2. So it's basically finding the interquartile range and then dividing that by 2. So we got for interquartile range earlier, 1.25. We just divide that by 2 and we arrive at 0.625. Now this gives us a graphical representation of where each data point lies and how they are positioned in the data set, the entire data set. So if we pay attention to Q2, if we count the number of data values to the left and right of Q2, we'll realize that we'll have a balance in terms of half of the data set would be on the right, half the data set will be on the left. If you look at Q1 and the position of Q1 as it relates to Q2, that first half, if you realize the numbers are evenly spread in terms of the amount of numbers there. So you have 3 to the left and 3 to the right of Q1. Likewise Q3. So basically what you're seeing are the quarters or the quartiles based off the position of these data values Q1, Q2, and Q3. In concluding, we know that raw data is considered unprocessed data. We know that data needs to be placed in order before finding quartiles, and the order means ascending or descending. In other words, from smallest value to largest value, or vice versa, from largest value to smallest value. Quartiles divide a dataset into 4 quarters, as you've seen from the diagram before. Interquartile range returns the difference between the upper quartile and the lower quartile. The end of another video lesson. I hope you learned something very, very useful for you to use in the future.
Much for me, much for you. That. Look how hard me I work, oh God. Now feel much me.